Welcome back, class. This is part two of our lesson one in our module three. This is going to be talking about normal distributions, what they are, just a little bit of an introduction to them. You've made notice distributions that have this classic bell-shaped curve. And a lot of them, especially when you have like a large number of data points, tend to have a really, really tall peak in the middle and it kind of evens out. And if you draw a curve over it, it's a very nicely looking distribution. In fact, we call that a normal distribution. And there's two parameters we talk about, our mean and our standard deviation. So because it's perfectly symmetric, the mean is going to be right in the middle. So whatever that is, in this case, it looks like it's around 7. And the standard deviation is what it's counting by. And in this case here, don't assume it's going to be 1. It could be 2, 2 point something, or 3. It really just depends on all the data. So if we look at this distribution here, um, the standard deviation curves for this scenario is the following. So this is talking about seventh grade scores for seventh grade students in Gary, Indiana on a vocabulary part of the Iowa Test of Basic Skills, ITBS. The scores are grade level equivalents, so a score of 6.3 indicates that the student's performance is typical for a student in the third month of grade 6. It's modeled by a normal distribution with a mean of 6.84 and a standard deviation of 1.55. So you can see that right over here, the mean is a little bit above 6, so actually closer to 7, 6.84. And the standard deviation is 1.55. So if you count by 1.5 approximately, that's where it's going in both directions. So if you take away the bar graphs and you just focus on the curve, that's what we're dealing with. So what we want to do right now is we want to try to sketch that curve out. And the way you sketch the curve is you draw your, so it looks like a little ghost almost. You draw that curve there, and then in the very center of that curve, you draw a straight line. Sometimes I make a dash going down. And right there is that's going to be your mean. Draw myself an x-axis. And that very center number is going to be whatever your mean is told. So in this case, 6.84. And then you take your calculator and you add the standard deviation and make little marks going approximately 3 standard deviations above and below that mean and mark those on the x-axis. So what we want to do is we want to estimate the proportion of students who score within 1 standard deviation away from the mean. So in this case, about what percent of that curve is shaded? Well, what would you guess? Maybe you'll say 50%. Maybe you think it's 70%. That's really up to you. What about 2 standard deviations away? So between 3.74 and 9.94. It's a lot more, maybe 90%, 85%. Take a guess. What about 3 standard deviations away? In fact, that's almost all of it. There's a little portion left undone. What percent is that? Not really sure, maybe 1% or less, but most of your data is contained within 3 standard deviations. So we're actually going to go to a website. We're going to go to Statlet, and we're gonna calculate these for sure. So let's take a look at the scenario we have going on for us. So if I click on normal distributions under probability, let's look at our data. It's got a mean of 6.84 and a standard deviation of 1.55. So there's our distribution. And what I want to do is I want to go between two values. So let's say 5.29 and 8.39. So what percent did you think that was if we go 1 standard deviation out in both directions? Let's calculate the area. Well, it turns out it's about 68.2%. Now, if I go 2 standard deviations out, that would be 3.74 and 9.94. What percent did you use? Well, it ends up being about 95.45%, so about 95%. And if I go 3 full standard deviations out, from 2.19 to 11.49, I get 99.7%, so almost everything, with just a smidge left over for the remaining part that you can see if you zoom in is underneath the curve and above the curve, 3 standard deviations out. So that's actually got such a distinct set of values that that's called the empirical rule. For normal curves, approximately 68% of the values are are within one standard deviation of the mean. 95% of the values are within two standard deviations, and 99.7% are within three standard deviations. These are rounded values, so they're not exactly these numbers, but those numbers are close enough to make good estimates from. So what we want to do is answer a few questions. So let's look at this example here, example 5. Many studies on automobile safety suggest that when automobile drivers make emergency stops, their stopping distances follow an approximately normal distribution. Suppose that for one model of car traveling at 62 miles per hour under typical conditions on dry pavement, the mean stopping distance is 155 feet with a standard deviation of 3 feet. For part A, we want to draw the normal curve that approximate the distribution of stopping distances. We're going to label the mean and the points that are 1, 2, and 3 standard deviations from the mean. So you want to make that rough sketch. It doesn't have to be perfect, but your goal is to have the mean in the center, so 155, and you want to count out three standard deviations to the left and to the right. And in this case, since our standard deviation is counting by three, that's what our scale is going to be. So we're going to add three, add three, add three, subtract three, subtract three, subtract three from our mean. It's good practice to write n parentheses the mean and the standard deviation. So the to let people know it's a normal curve, usually you'll put n with your mean and your standard deviation, your mu and your sigma right in there. Um, so that way, if everything is not perfectly labeled, at least we'll know what the values are that are going to be on the axis. So now we can answer a few questions. Part B, what percentage of cars would make more than 158? So for part B, we want to know what percent is shaded here. Now remember, we're given that 68% of this data is between those values. So if we know this is perfectly symmetric, we could take that 68 and subtract from 100% or 0.68 from 1. And then since this is the right half, simply divide that number by 2. So what we'll do is that we're going to take that 68, we're going to subtract it from 1. And then since we're only dealing with the right side, we're going to divide that by 2. So we'll have 0.32 divided by 2. And that's going to give you about 16%. Let's verify that. So if I want to go above a number, I can actually plot this in Staplet. I can do the mean 155 and the standard deviation of 3. And I want to go to the right of a value, and I'll put that value at 158. And the area is about 15.87%. So we rounded it to 16%, which is fine using that empirical rule. Part C. About what percentage of cars of this model would take between 149 feet and 158 feet to make an emergency stop? Well, so what you can do on this problem here, let me back up for a second, is we can actually calculate all the individual sections. Sometimes that's easier to do. So what I'm going to do in this case is I'm going to draw myself some lines, and I'm going to try to figure out each of these different sections here. So the first thing I'm going to do is I'm going to look at this, and I know that that's 68. So I'm going to just divide those by 2 and get 34% for those. I know that this is 95. So what I can do with that 95 is subtract the 68 to get what's left over on the outside. 95 minus 68 is going to be uh, 20, 27. So what I do with that 27 is divide by 2, and I'm going to get 13 and a half. So 13.5%. So these are each going to be 13.5%. And then the remaining ones I can do in a similar way. Now, in this problem here, I'm only concerned about the 149 to the 158, so I really only need these three. But if you see those, all I got to do is add them together. You can actually get all the different values, so I went ahead and did that. So if you can see those percentages, you get about 0.15, 2.35, 13.5, 34, 34, 13.5, 2.35, and 0.15%. So these are all the percentages. It wouldn't be a bad idea to have those memorized. It's not hard, and so you can get a lot of answers this way. So now I can say, well, between those two numbers, I'm going to add up the percentages in there, and I'll have 13.5 plus 34 plus 34. Well, that's going to add to 81.5%. We'll verify on the applet. So I want to do between two values, and we'll say 149, and the other one was 158. Calculate the area. And can you see it's about 81.86, and we said 81.5, so that's a pretty good estimation. All right, lastly, this is a check your understanding, although it's a lot different than the one we did before. So take your time and read through it, see if you can understand what's going on here. Mandarin oranges from a certain grove have weights that follow an approximately normal distribution with a mean of 3 ounces. About 95% of the mandarin oranges in this grove have weights between 2 and 4 ounces. We want to find the standard deviation. So in this case here, we need to really visualize what's going on with this picture. What I would do in this problem is sketch a curve out. Know that we're going between 2 and 4. So I'm going to mark 2 and 4 farther out because we're talking about 95% of the data. Now, do you remember how many standard deviations 95% of the data is? Well, it's two standard deviations. We can go back to this rule here if you remember. Two standard deviations out. So 95% is going to cover two standard deviations. So we're actually counting four unique spaces in that. So with it being two standard deviations from the mean, that's 95% of the data. There's actually two standard deviations to the right and two standard deviations to the left, which means that there's a small interval between the 3 and the 4 and the 3 and the 2. So if we kind of cut that in half, you're going to get 3.5 and 2.5, which means that the standard deviation that it's counting by is this distance, 0.5. So you can kind of visually see that, but also you can calculate it too. And here's how. Since there are four units on the axis between 2 and 4, we can take that difference between these two numbers, so 4 minus 2, and divide that by 4 units, and that'll give you 2 divided by 4, which is 0.5. So our standard deviation is 0.5 ounce or ounces. That wraps it up. So let's do a little lesson summary. Remember from our previous video, we talked about the percentile, the percentage of people at or below U. The standardized score is the value minus the mean divided by the standard deviation. The cumulative relative frequency adds the percentages up until you get to 100%. Remember our summary for adding, subtracting, multiplying, or dividing or z-scores. None of the shapes change, but the center can change with all of the operations, and the variability only changes with multiplication and division. And with z-scores, the mean will always be 0 and the standard deviation will always be 1. Finally, the empirical rule for normal distributions, 68% of the data falls within one standard deviation of the mean, 95 within 2, and 99.7 about within 3. That concludes our video. Thanks for watching.